Kano becoming a ROS developer. I'm Desire, and today we've got Oluwademilade, who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation on that. So what I'm going to do is to hand over the platform to him so that he can begin his presentation. All right, you can start when you're ready, Oluwademilade.
So I'm going to connect to the native robot first. So I'm going to go to the directory where our files are stored. So now we have a list of all the files that are inside the directory. What we want to run is the robot interface first. That will allow us to be able to connect with the robot. So that's first. So we need other terminals, one to run our obstacle avoidance code, and the other for robot statistics. Let me just copy this here. So I'll have to do it again. So next, yeah. Okay.
Try using tab. It will autocomplete for you. Yes. So.
Okay.
All right.
Yes.
Okay, so okay, you can reduce the size of the terminal so that you can see what the robot is doing. So maybe a little bit.
Right. If you want to launch the statistics.
Okay, sure.
The threshold we used was 0.35 meters. So that's why this sends the obstacle in front of it. That's why it turned to 30 away.
Okay. Okay. All right. Looks like it's working as expected. So maybe let's leave this window on the side, right, so that you can see what it's doing as you take us through the code. So explain to us how you managed to get it to exhibit that behavior, especially this obstacle avoidance section, right? So we want to know, what are you doing? How do you monitor how far it has moved? And how do you make it avoid the wall or find the distance with the greatest space?
The distance covered and every other parameter, I monitor that through the robust statistics. I'll go through the code later. So basically, this is distance covered first from the starting point, which is here. The direction is also shown there. And this hold-on position, talking about the odometric position, that's where it's from the origin. That's x-axis, y-axis, and z-axis. Z-axis should be showing 0.0 because it's like a 3D axis. So the robot is moving x and the y. That is why the z is showing 0 and the x and y we are getting reduced. Now, concerning the orientation, so the pitch and the robot is stationary, is view too. So the roll and pitch will also be showing 0 because as you know, roll has to do with sideways movements like a plate tilting sideways. The pitch has to do with like I'm using a pin illustration tilting backwards, and the yaw is the left and right movements. So our roll and pitch also giving 0 0, and our yaw is what is giving us reading.
Yeah, really good, really good.
So concerning that, let me go to the let me open the code editor in the browser so that will be easier for me to explain it.
Okay. So, okay, you spoke about things in a very interesting way, and I very much appreciate it because it puts into perspective what is roll, what is pitch, what is yaw. But can you talk about
Yes.
them relative to axes, right? So, uh,
Yeah. So
s-
the
so let's first start with roll, right? It's rotation relative to what axis?
roll is rotation relative to the x-axis.
Okay, good.
Pitch relative,
And pitch?
sorry, pitch relative to y.
Okay, yes, good. Yeah, so it's very important, and I like the way that you spoke about them because it gives intuition, but in robotics, the convention is that the front of the robot is where the x-axis is pointing, right? That's why I was asking you to speak about them in these terms, so that anyone who can be watching can also understand based on your explanation, which is really good, by the way, that they understand that pitch, which is tilt to the back or to the front, i.e. rotation in the y-axis, they will also be able to
Yeah,
switch between the understanding between which axis of rotation and what it does to the robot itself. So very well done on that.
thank you. So this is our code. The first one is our Shebang script, sorry.
Mm-hmm.
That's what tells us that okay, the battery does not come.
Mm-hmm.
This is intro. This is importing, basically importing the robot for of us to write in it. I'm just going to call it and buying some parameters that were there. And then we have the trap function here. This trap is basically telling me that okay, there's a mistake or something. It can stop the robot cleanly,
Mm-hmm. Mm-hmm.
automatically stop the robot. And when it has stopped it, it's going to set the linear velocity to 0 and the angular velocity to 0. We have the sequence there, which represents the control C and the system, which is the Q command. So
Mm-hmm.
immediately we automatically press control C on the Q command. The trap automatically sets it to 0. So the robot stops moving.
Mm-hmm. Very nice. Yep.
And this is a function called safe range. So when I was doing the project, I realized that there was some times where my robot was getting infinite values.
Mm-hmm.
So I read more on that and I found out that we're using a LiDAR sensor. And the LiDAR sensor works based on the principle that, okay, if there's no obstacle in front of me,
Mm-hmm.
if that's scanned and it has like a max limit, there's no obstacle in front of it, rather than reading the max, it's reading infinity.
Mm-hmm.
So this is different from normal sensors that I've actually worked on, like let's say ultrasonic sensor, where if it scans for the maximum value and does not see anything, it just comes back and uses the maximum value as what was scanned for. But for the LiDAR sensor, it gives infinity. So in order not to have things like infinity there, we use this function here. So what is this saying? It's saying that if I read infinity, not the number or minus infinity,
Mm-hmm.
to make the distance 10 meters.
Mm-hmm. Mm-hmm. Okay. Yeah, I like that. Okay.
Or else, if it's not any of those things, just return back the original reading. So
The actual value.
that's this particular function here.
Okay.
So
Okay.
this is another function here. I found that it was repeating a lot. So rather than just repeating a lot in the code, just create another function where I can call it anytime it
Yes.
applies. So this is basically local range distance to move. The distance to move is the range minus the threshold.
Right.
The threshold, which we realize later is 0.35. So it has scanned. So what's the range? Let's say I have 0.5 meters now. So we're going to move 0.5 minus 0.35. So yeah, that would be 0.15. It's going to move 0.15 meter. Why? Because I have not scanned because there's an object there. So I don't see the object. So that's why this is there. This is
Mm-hmm.
basic calculator. This minus L sign is basically saying that it's basically used for infinite values and decimal points. That's what it's basically used for. Then this is if statement. Again, I want it to return in negative numbers. So I have an if statement here to ensure that okay, the distance to move is actually greater than 0.
Mm-hmm.
If it's
Mm-hmm.
not
So
greater than 0, it's going to risk greater than.
okay. So I want
Sorry, are
to
you asking?
Yes, I want you to explain a bit more around that. So let's say line number 20 to line number 32, right? So you have got
Yeah.
a a value that you call local, right? Can you explain why you call it local in that scope?
Oh, it's just local is applying to that particular scope.
Right.
The
So,
local range is just like passive parameters and arguments. So we're just using it as like a default parameter where range can tell other things later. But for now, that's just what it's saying.
and can you show me how scope is regulated in the this base script? So,
I don't think I understand.
what marks the beginning of scope and the end of scope?
I don't think I understand.
All right. So let me try to explain it in different terms, right? So the fact that you declared your variables as local, right? You are trying to confine them to a particular scope, right? So if
Okay.
yes, yes.
I'm saying that it's the function that marks it. The function at the end of the function marks it. That is only
Okay.
applies in this function. That's what it's saying. Yeah.
Right, exactly. So what would happen if you try to access those values outside the function?
It won't. You can't change it. It's only what I'm.
Yeah, I think I'm losing you a bit. So yeah, try that explanation one more time.
If I try to access the value, I can try to get this value.
Yes.
Is it one?
Yeah, yeah.
And it will get replaced by the way it is being applied. It will get replaced by the value that is in the like in this kind of scenario here. Sorry, in this kind of scenario here,
Mm.
the answer I get here will be replaced with this value here. That's what it's saying.
Right. So that's overshadowing, right? So you're speaking about the uh, like kind of the reverse of it, right? But the actual way that you're doing that for is, or the actual main reason why you're doing that is to actually confine it to the function. So that explanation is good. I just wanted to probe your understanding in that direction to see if you understood what we are doing there. And the other thing is, I'm going to flip the question and say, okay, if you are going to want to use the function globally, right? How would you declare it in that function, in that move to threshold? If you wanted to use the
I'll
variable
change it from
globally.
local. I'll change it from local to global. I'll simply call it declare it outside and I'll change it to global.
Hmm. And so, okay, you also spoke about the fact that the variable can be overshadowed, right? So, what does local
Yeah.
do in the event that you have another global variable with exactly the same name, right? What does local do? Does it overshadow that global variable, or what does it do?
The global, if the global is there, then the global means it can be changed later. But
Yeah,
local simply confines it to the function.
right. So there's okay, yes or no? Is there going to be overshadowing if you have a name that is exactly the same with the one that's in the global scope if it's
No,
declared as
it's not
local?
overshadowed. No.
Okay. All right. All right. Yeah, good stuff. Okay, let's go on.
Okay, then I think yeah, the distance to move range minus threshold. I'll give an example of that. And
Mm.
if it's greater than one, the encode time to move to scale equals to just basically approximation. So my average that I give this was 0.1
Mm-hmm.
as the average that I give to move. So then the time to move is the time that's collected. And this minus one was because I found out that the rows are a bit of time in responding. It processes, so the minus one is to cover any slight delay, any slight shifts,
Mm-hmm.
so that the stuff will not crash. That's the use of the
Mm-hmm. Mm-hmm. Yeah, understood it.
so then this if function, then after it sets the velocity linear back to zero again, and this equation just represents that in our terminal force. This is this function basically saying that like I started when we were running the code, I started by running the robot interface first. So in case the robot interface has not been launched yet, this
Mm-hmm.
will keep happening. So they telling us no not found, no not found. Flip 1 second, check again. If it's all this is
Yeah.
no not found, no not found. once the node has been found, then it says node ready, start the calculator.
All right.
So now
All
we're
right.
just getting to the main code itself.
Mm-hmm.
The linear velocity, angular velocity is set to 0, the threshold 0.35, and the while loop is the left range or front left range. So I'm basically getting it from the robot functions that are imported already. So we're just giving these new names, new variable names.
Mm-hmm.
That means that. So then this is our if conditions. If the front left is free and the front is if the front left is not free, that's the minus EQ 0. It means the return is 0, which means it's not true. So if the front left is not free, if the front is not free, if the front right is not free, then it's going to check left range and right range. If let's say greater than right range, then move in that direction. That's the angular 0.7859. The reason I use this number was because we have four cardinal points and we have like northwest, northeast, north, southeast, southwest. So I
Yeah.
took those into consideration. So I used 8 possible turning factors. So
Okay.
convert it from pi to degree to radian. That's 45 degrees basically. 360 over 45 degrees. Then convert from degree to radian, we have this. So this is why I used this particular value here.
Yeah, very well done there.
In particular time, the else statement is this one and left range.
So
You have another scene.
okay, I see. Okay, you're using a constant sleep time. All right. Yeah, okay. Very good implementation. Very good. You went to great lengths to actually give this resolution, and I like it very much. Okay, let's go on. Yep.
Another scenario, front left is free, front left is not free, 0, 0, 1. So both direction that is free is right there. So just move here. Then we have front left is not free, front is free, front right is, then move forward. Just calling back the function that we have here, this is what I was talking about before. This front range here basically means the answer I get from the front range, replace it with this value here. Yeah, and then it starts to move that direction. Then
All
we
right.
have 0, 1, 1, move in the right direction. Then we have 1, 0, 0, move in the direction that is free. 1, 0, 1. If the left is greater than the right, if there is also that particular region, move in that direction. And 1, 0. Lastly, if everything is free, move forward. And the sleep function.
Okay, all right. So let's go back to the screen where the robot is, right, so we can see a bit more if it's still patrolling correctly. But your implementation says very well that it's not going to fail. Maybe it might in some very extreme cases, but it's very well thought out.
There was a time where it was failing,
Mm-hmm.
where I found that the distance between so let's say the distance was 0.39 and
Yeah.
0.34.
Yes.
So the rows got stuck on the cycle. It got stuck on an infinite loop where it was not moving, it was just staying there. And the function was still working because the statistics were working, the step parameter was working. It just got stuck in an infinite loop.
Mm-hmm. And how did you deal with that?
I tried to remove I thought of removing the range I did, the function I did. It was cleaning the values. I thought of removing this, but it's going to affect this later. It does not consider every possible, if one is cleared, one does not, that kind of thing. It doesn't consider every possible outcome for now. So, yeah.
Okay, so I want us to unpack the problem in a bit more detail, right? So that we can find a solution instead of avoiding it. Like, how do we still work with that system and avoid oscillation, right? So maybe would you describe to me the cases where it was getting stuck? Was it like oscillating between left and right, or what was the case?
I think this is the case now. Yeah, this is the case here.
Mm-hmm.
This is the case now. I can say the parameters are set to the return one.
Yeah.
The return one. So what's running only one? It means really setting one of the conditions correctly.
Right.
I think so. Reading the value that is reading here, if I check the function, see, the function object with able to check the readings that the scope is reading.
Okay. So
So it's reading a like 0.3 for 0.3 is very close to the threshold, but it
Yes.
is not the threshold yet. So it keeps on repeating, keeps on getting an infinite loop, it doesn't know what to do. So it's
Ah.
like that kind of scenario. Yeah. So that's the issue.
So okay, so it's not the turning issue, it's just that it's not getting a threshold that is above the value that it wants.
Yes. Yes.
Okay, all right. This is, yeah, it's an interesting problem. It's an interesting problem, and I'm trying to think, um, what could you do, right? Maybe you could do some alteration, right? So I'm gonna suggest this, and you tell me what you think, and also for the sake of making your code better, right? What if,
So,
yeah, what if you had set a counter for your loop to find cases, right, when it's stuck in this loop, and then
mhm.
when your counter hits a certain value, you trigger a like a veto movement, right? So a movement that's just going to say like 10 more than certain number of degrees, right? So give this a thorough thought and give me a comment on it, because why did you not think about it in this line after this uh, very well
this is
thought of
this is what I'm
implementation?
saying. This the issues from this place here, this code here.
Mm-hmm. Mm-hmm.
So if the threshold is like, let's say children is reading like 0.36 now. Yeah.
Mm, mm.
So that's 0.36 minus 0.35, which is like 0.1.
Yes.
So the distance is greater than that. But when is this thing, when I move here now, the 0.1 over 0.1 will be 1. Once
Yeah.
once the time has been subtracted, it is not greater than 0. So that's the issue of the issue. The distance is not greater than 0. So the time to move is not greater than 0. So it's just stop there. It's keep on reading, it keeps on, because that is actually free. But this, so is it I remove this line of code here? I can say
Yeah,
if
yeah,
you
yeah. I
remove
can.
it, that's
Yeah.
what is going to make it better.
It's either you remove it, or you actually find a way of trapping it, right? Or of like realizing that that is what is happening, and then having maybe another if then else do this, right? So when distance is uh, zero or less than zero, what do you do, right? So it's because you're talking about it, you already understand like what is the precondition to that occurring, right? So because
Yeah.
you know that, you could put a guide into it, right? Or you could put a guide of how to fix it as an edge case.
I hear you have work on that. Work on
Yeah.
that.
No, it's an extreme case, right? Already your implementation is very, very, very well done. Anyways, thank you very much for your presentation, Oluwamide, right? If I'm pronouncing your name right. And so we're going to finish here, right? And then you hang around, and then we finish our conversation on Zoom. By the way, one more time, thank you so much for being here. All right, everyone, this was Oluwamide's presentation, and I would like to encourage all those of you who would want to try this course or any other one that we offer certification on to do so, and then you can also come and showcase your work. So until then, keep pushing your Rush learning. Bye bye.